Okay, so in the last video we introduced the chain rule and we ended with this problem right here. So in this video what we're going to do is go through four more examples of applying the chain rule just so you guys can get some practice doing it. Now, the thing with the chain rule, just like with a lot of stuff, practice makes perfect. So if you're still a little bit shaky after these examples, I would highly recommend looking at the section in your book. I think 3.6 is the chain rule. Check out those odd numbered problems in the back of the book because those are the ones you have answers to. That would be fantastic practice for the chain rule because again, the more you do it, the easier it is to see the pattern, and eventually you don't even have to think about it. The chain rule just becomes very natural. It just kind of flows. All right, so let's start right off. Why don't you take the derivative of this function, try to pause the video and see if you can do it. Alright, so if you're giving it a shot, let's see what you got. And please realize that I'm not simplifying any of these equations. The reason why I'm not doing that is because the simplification, that's like algebra that comes later, okay? That's not the most important thing. The most important thing is that you can just straight up calculate the derivative correctly, okay? So let's look at what we did here. Again, when we're taking the chain rule, we always start from the outside and work our way in. In this case, the outermost thing we do is take the secant, and the derivative of secant of x is secant x times tangent of x, which is why we have secant of e to the 3x plus 1 times tangent of e to the 3x plus 1. Remember, we take the derivative of the outside, keeping the inside the same. Okay, so that's that derivative. Then we take the derivative of the next thing we do to that is we exponentiate it. We do e raised to the power. Well, remember, the derivative of e to the x is just e to the x, which is why we just repeat e to the 3x plus 1. A lot of people get tripped up applying the chain rule with e to the x because you just multiply it by whatever that thing is because the derivative of e to the x is just e to the x. So don't fall into that. Then finally, we take the derivative of the innermost thing, 3x plus 1, which the derivative of that is just 3. So multiply all that stuff out, we get what the answer is. Okay? So if that's a sufficient warm-up, let's try doing the next one. All right, again, give this one a shot. Pause the video, try to do it on your own. All right, if you've given this one a try, you should have gotten something like this. So again, we ask ourselves, we start from the outside and we work our way in. What's the outermost thing we do to this? We take the natural log. The derivative of natural log is 1 over x. So this is that 1 over x right here, but remember, we keep whatever is inside the outermost function the same. So instead of being 1 over x, it is 1 over sine squared x. Now what's the next thing we do to this? Oh, remember the last video, don't be confused. The next thing we do is not take the sine. The next thing we do is square something. So the derivative of x squared is 2x, which is why we have 2 times the inside. The inside of what we squared sine of x. So we take the derivative, but we keep our inside the same. Our inside in this case was sine of x. So the innermost thing we have of this is just sine of x, and the derivative of sine of x is cosine of x. We multiply all those terms out, and again, we get the answer. Now, remember what I said, I'm not simplifying this stuff, okay? If we really wanted to simplify this, we'd cancel out a sine right there, and we would end up with 2 cosine over sine, or 2 cotangent. You could say that if you want to, perhaps on the AP exam. That's good practice because they often simplify their answers, but for now, the most important step that you can show that you know how to do is just taking the derivative. Again, simplification, that's algebra. You know how to do that stuff, that comes later. All right? So let's try another example. So let's look at this problem. 2 tangent of cosine of x. All right, try to do that one on your own. Okay, if you've given this one a shot, you should have gotten this. Remember one of those rules that we discussed when you multiply a function by a constant. Really, you could consider this to an outermost function, but you actually don't have to. Anytime you have a constant in the front, the constant just stays in the derivative. So nothing really happens to that, which is why that 2 just stays there. The outermost thing we do to this is we take the tangent of it. and the derivative of tangent is secant squared, which is why we have a secant squared here. And again, the inside is cosine x. We keep the inside exactly the same. Then the next innermost thing we do to this is take the cosine. So the derivative of cosine is negative sine. So we multiply the final answer by negative sine. So we end up getting secant squared, or secant of cosine of x squared multiplied by negative sine. Notice that I use lots of parentheses when I'm giving my answers. That's because you could get into a lot of trouble doing this. Like, for example, if you didn't close your secant parentheses and you put that negative sign inside there, first of all, you might not know it means multiply by negative sign. Finally, you might put that multiplication inside the secant function, which would be wrong. Be very liberal with your use of parentheses when doing the chain rule. It can avoid some mathematical mistakes that might happen. And I'm just, knocking over stuff on this desk. That's what we do in math. We're wild. We knock things over, okay? Pretty sure that stapler is broken. Look into that a little bit later. Okay, so let's do one more example, and then you guys are going to be pros. All right, try to do this one. This one's going to be a little bit tricky. I'm going to warn you, but just give it a shot. All right, so if you've done this one, what you should have gotten was something big and nasty that looked kind of like this, okay? So what's the outermost thing we do to this? Well, the outermost thing is we do the inverse sine. So remember that the derivative of inverse sine is 1 over the square root of 1 minus x squared. So that's what we have. We have 1 over the square root of 1 minus. In this case, our x is whatever was inside the inverse sine function, which would be the quantity 2x squared plus cosine of x raised to the negative 3. So we take that whole thing and we square it, okay? So the next most inner part of this is what? Well, it's that negative 3 right there. So the next inner thing is we raise something to the negative 3. The derivative of that will be negative 3x to the negative 4. So you see right here we have our negative 3 right there. We keep our inside the same. In this case, the inside of something raised to the negative 3 was 2x squared plus cosine of x, so we keep that the same. Then raised to the negative 4, that's where that exponent comes right there. Then the next most inner thing we have is this function right here, okay? And then there's nothing else inside that. So the derivative of 2x squared will be 4x. The derivative of cosine of x will be negative sine of x. So we multiply all that out. We end up with our final answer. So again, it's very important that in this video that if you're getting confused with this stuff, go back and look at these examples a couple more times. If you're still confused after that, try the odd-numbered exercises in chapter 3.6. And if you're still confused after that, let's meet during tutorial and we'll talk about some of this stuff. I did just kind of improvise all these derivatives. I'm pretty sure I didn't make a mistake on any of them, but if you guys think you caught one, let me know that too, though I think they're pretty watertight. So anyway, I will see you in class later.